Hello, I'm Chris Athenis. I'm a KMP developer, tech support. They said they're coming out to close it up Tuesday, so we'll see on that. Today I'm going to be reacting to this video by Liam Walsh. He's got 325 subscribers. Go give him a like and subscribe. He has some different ideas here about some things he picked up in programming for the last 10 years. And I definitely let's just go through them. Let's listen to me say in the context of adventure-driven development. That's kind of how I'm bringing this together. Let's get going here.
I'm 33 years old at the time of recording this, and I've worked as a developer for over 12 years in various roles with a variety of brands and businesses. Here's 30 programming truths I know at 30 that I wish I knew at 20. Number 1. Watch out for long chain dependencies. That meme about no modules being the heaviest object in the universe is true for one main reason: long dependency chains. Dependencies are like a tower of cards. You knock one out, they all come tumbling down. Be wary when packages have deeply nested dependencies.
Yeah, I mean, with KMP, it's not as big of an issue, but in a TypeScript and JavaScript projects, this can get out of hand because Node up front, it can get completely out of hand. I mean, it can with KTOR, even in the context of KMP, if you're using KTOR. It's not as terrible, but for what he's talking about, it can get ridiculous.
And don't fall into the trap of creating packages or modules that keep stacking up and up and up. Number 2, you should learn multiple languages. I started off with...
Yeah. I think you should learn at least Kotlin and JavaScript. Yeah, though, because one is a dynamic language that everything can change on the fly. It's more like what Alan Kay was talking about. And then you have this compiled style language, which Kotlin, gets compiled down to the bytecode for the JVM, which is sort of how a C gets compiled down to the bytecode language for the microprocessor. It's the same idea. But as long as you know that there's two ways that things are generated, one's like a soft language, the other one's like very highly confined. One's like type free or type implied, and one is like you got to have types. So or types are preferred. It's those two flavors going back and forth. They both have their strengths and weaknesses, and it's important to know those two. But you don't have to learn all those other ones, because once you learn those two, then you got all the other ones. Like the other ones, like, oh, it's just like this. It's just like C or just like Kotlin, but it does this, it does that, it does this. Like yeah, it's all the same shit. It's really annoying that they had so many languages, but Kotlin, kind of pares it down to what you really need to do all the different platforms without having to learn 16 different languages and all the quirks and release cadence and we got 0.1, 0.2, and we took away, deprecated that. We brought this. It's like just when you have one language, that's enough. Or if you do like 5 or 6, and you're just trying to keep up, this is ridiculous.
HTML, JavaScript, and CSS. As plain and bog standard as you can get. I didn't really jump into using more languages until about 3-4 years into working as a developer. By that point, I was so comfortable with what I knew.
Learn one well, and then the next one you learn will be like, oh, okay, this is different. Or this is different. This is different. This is different. You already know kind of what to look for.
Struggled to try anything else. It felt like starting from scratch. This was a mistake.
That's gonna be like that the whole time. It's gonna be like that the whole time, and when it stops being like that, it's gonna be like fun or something. I mean, KMP is like on the edge line for me because of the AI assisted tools. They kind of in the edge between fun and doing like how I first started programming, fun and a little challenging, but it's gonna continuously do that the whole time. And if you're not used to that or think it's terrible or you just want your little tool, I mean, you can always go back to the club, these homebrew microcomputer clubs that they're frozen in time, but they're still making stuff, picking new programs, everything like that. And you can master that, something like that, and be a throwback, I guess.
Those languages trapped me in an era of development where I had no awareness of other languages and what they could provide.
I love that stuff, by the way. But it's if you're going to do modern development for modern stuff, hold on here, I got my. Yeah, if you're gonna do modern software development, you're gonna have to keep up with the trend that's happening. That's been like that the whole time.
And even robbed me of a few job opportunities. Number 3, always check for truthy values. Always avoid
it's JavaScript thing.
Negatives, and almost always check for truthy values. Reading code where you're checking for truthy values is so much easier to read. If you have to use a negative naming on a variable.
Yeah, okay. I guess he's way saying like check if the value is true. Don't check if it's false. Like you prefer to check if something is true, unless you absolutely have to some way somehow check if it's false. But yeah, checking if it's true, then. Following that, doing that as a normal path as you're checking things in your code definitely makes things easier as opposed to like checking for false. I think that's what he's talking about.
Like is not a pizza, then never pair it with a logical not comparison. This creates a double negative, which is just a pain to read.
I agree. This is super annoying. They'll just say is pizza. That'd be easier.
And creates cognitive load when it's not necessary. Number 4, the language you start with doesn't matter. I already mentioned what I start with.
True.
Some people argue and say start with something else, but the truth is, what you start with doesn't matter. It's just the fact that you get started that matters.
Yeah. I agree. You're not gonna know the whole thing. You're not even from the start. That's why my course, like bring you through it from the bottom to the top, and you don't have to know everything about assembly language or binary codes or how the things are put down on the chip or basic, or you don't know the whole thing. You just know the first 10% and see how it works, and everything's just kind of a variation of a theme. It's going to go down line by line. You can do a loop. You can branch to some other thing. You can do a subroutine, come back. And there's only so many things you can do. But once you learn it, once you learn one deeply, it's like easy to transfer to other stuff.
Do a little bit of research into what you want to build or what area of development you want to work in. Make an educated choice, and then go from there. You're not
exactly. Just start somewhere. They're also all variations of the same theme. So once that's his point. Is like once you get down in it, for sure, you can keep going in different directions.
bound to any one language, and learning your first language makes learning the next one easier, and then so on. Number 5, practice data manipulation, especially arrays. The majority of programming software revolves around moving data from one place to another.
Yeah, 80% of code. So IBM did this study, and 80% of code is just mapping one thing to another. Okay, filtering. So just looking for stuff, or getting rid of stuff, getting the data set smaller, then mapping that to something else, or transforming it to something else, doing some calculation on it, and then putting it someplace else. That was 80% of the code. So all this leak code grinding on all the different algorithms and all that stuff, a lot of those algorithms are all just abstracted away, and 80% of the code is just this one thing. And you'll find out if you're going to do front-end code, that's basically it. Now, back-end code, it's going to be a little bit more than that, but not much more.
Manipulating, shaping, and trimming along the way. So get really good at shaping and understanding data structures. In particular,
map, filter, transform.
Get really good
filter, map, transform, whatever.
with arrays. They're in every language and will be the most common type you work with. Most of the time will be sorting, filtering, and trimming data that's stored in an array. Number 6, master your tools. Speed and efficiency trump the latest and greatest. There's no point using the latest language or framework if it takes you 2 to 3 times longer to get the same task done as if you could do it in the same stack that you're comfortable with.
Yeah, true. If you have your choice, use the stack that you know. Of course, yeah, totally if you have your choice. That's what I'm talking about. Collin's like, I think Kotlin could be like, I mean, I don't want to say it's the last one, but dang useful for like everything that we're trying to do right now. And maybe if there's something in the future changes, whatever. But it's very concise. It makes sense. They've thought it through quite a bit. They've had wrangled with it for 10 years. So yeah. But Kotlin lets you do scripting. So Kotlin's everywhere, but and also just like JavaScript. Kotlin's everywhere, JavaScript's everywhere. But Kotlin lets you go more native. JavaScript's always got to have some layers, some V8 engine running thing.
Software requirements change. In this high-speed world, being able to deliver quality quickly matters. Number 7, get really comfortable with typing. This one might change in the future with AI tools and voice control getting a lot better for software, but for now, we're all mostly typing. If you're getting
it's just not going to go away. You get used to it.
in long, uninterrupted blocks of time for coding, then you'll simply get more done by being able to type quickly, efficiently, and accurately. It's what we spend the majority of our time doing, so it makes sense to actually give it some practice. Find a keyboard that's comfy for you and get really cozy.
Yeah, getting a fun keyboard. Yeah, I do recommend this. This is a really nice keyboard. Having a good, fun keyboard that you actually like to use, definitely a thing for programmers for sure. And having a selection of them and like switching back and forth between them definitely is fun. It does definitely makes the job a little more enjoyable.
Cozy with it. Look at things like Vim motions for better code navigation without having to reach for the mouse.
I've heard this Vim thing. I mean, I have the little trackpad right here underneath the thing. It's fine. A Vim thing's a little overrated. I mean, if you're typing a lot, I don't know why you would be typing so much, but like, I've heard people like say they really swear by it once they go up the learning curve, but I haven't done it in 30 years. I don't see the need to. I get fine enough. And you're not really writing as much as you think. You're mostly reading, so get good at reading. Yeah, I get super good at chunking down the page and scanning and like just looking for keywords. I mean, you get good at it anyway, but like that's better because you're scanning down, trying to take it all in. That's
have fun with something like monkey type. Number 8, embrace your curiosity. Lots of people will tell you to go this way or that, learn this thing or that thing, take this career path or that. Instead, listen to your mind.
Yeah, if you get either one, you're gonna say it's the wrong one. So it doesn't matter. You just have to do both. You're gonna do lots. That's just part of the thing, right? Is going down these different paths and trying not to like a scientist. Sorry, it's like a scientist. It's work. It sucks, and that's why they pay you.
What do you think about when all is quiet with nobody around? What blog or Twitter post caught your eye? Follow these trails of curious thought and then dive deeper. Genuine curiosity will lead you to places other people simply won't go because they don't get that.
Yeah, that's where that adventure-driven stuff is coming in. Where to be a good developer. Now, if you're just trying to get a job for this next year or two, ignore this advice. Just don't be curious at all, and you'll eventually get fired and not have be like, oh, tech industry sucks. It's like, no, it's just like constantly changing. So if you're not a little curious, you're gonna be left behind. And if you're like, if you have to follow each trend before it comes that you're forced to kind of get into, that's just so unenjoyable. And that's why a lot of people burn out.
same feeling or spark. That's where you can shine, in the place that you're intrinsically drawn to. Number 9, avoid the else-if pattern. Avoid else-if like the plague.
Right.
It's verbose and creates a strict linear...
Yeah, this is garbage. But this is a leftover, like in my course I talk about, this is a leftover from a bygone age when we just didn't really understand this before the switch statement arrived.
form of logic that could be better simplified with something like a switch statement. Sometimes they can be combined into groups and have standalone if statements, and then a final default return at the end of the function. It's just neater and easier to follow. Number 10, try both a scripting language and a compiled language.
Yeah, default return at the end, I love it. Or in early returns, I love it. I'm an early returner. Default at the end, the success at the end.
They both have different strengths and they both have different weaknesses. They both behave differently, and it's a good idea to try at least one of each so you can get a feel for how different they can be and where they're similar. The workflows tend to be different between the two, so you might find one style suits you more and your values better than the other. Number 11, and I'm going to stop counting with the fingers now. Try both object-oriented programming and functional programming.
Yeah. I mean, this is falling out of favor, but it still populates the language, and there are times when you're kind of using it as a thing. I don't know. It's like, so in my course, I talk about the difference between BOOP, which is the Bugayinko's or object-oriented style programming, or back to object-oriented programming style that Alan Kay promoted. So we're talking about Alan Kay's ideas. So there's two styles. One that's about messages and containment and being actual real object, the world reference. And then there's a C++ thing, a monstrosity, which I call COP, class-oriented programming. So there's this class-oriented thing, and there's the object-oriented, or the back to object-oriented programming, which is Alan Kay style. And then there's the Stroop C++ monstrosity thing. I don't even know what that thing is. And that's the COP, the class-oriented programming, which is, so I talk about that in the course. And you do have to know both, but generally lean on the functional style because it's way more testable. Like Compose and KMP, the whole UI layers is basically this functional stuff. And you pass functions around instead of having to pass an object that has functions inside it. You can just pass functions around like their first class citizens, which is called Lambda, whatever. But and you can have functional parameters, so you don't have to do all this OOP stuff. You don't have to like shove it in there with an adapter, singletons, abstract. It's like you don't know. And it's shallow hierarchies are really what we should be doing, not these big long hierarchies we have to go through and all the different stuff. It's ridiculous. It just got ridiculous. So the functional side, and like both the Fred's Road Trip Storyteller and all the apps I've done for Compose are all in the functional style. And you still use pieces of OOP, especially like the OOP, some of the idioms out of OOP, like classic OOP with classes and stuff like that. But I'm going to be using them in the Alan Kay style, so there's no statics and oh god, I go into all that stuff in the series. So if you're interested.
Two paradigms, very different approach to how code is written and behaves. Like the last point we mentioned, they both.
It's not that different. It's just one will get you caught up, but all tore together like this. The other one will be all ready for parallelization and separated concerns and all that kind of stuff. So that's why I'm like, oops, kind of bad news, because it's usually the COP styles when they're talking about it was like this monstrosity, like odd creature. But the Alan Kay stuff, totally legit. That's the BOOP.
Have strengths and weaknesses. People get very zealous about these two things, so it's best to try both and understand how they both work. I was brought up with object-oriented programming, but found that I much prefer
stuff to do because there's a lot of confusion. So in my course, I went through the whole thing, and I saw what the differences was, and I found Alan Kay and Yegor Bugayinko. And I was able to figure out what the hell was going on because I would get in these code bases. It's like, this stuff is just procedural with a bunch of extra stuff going on. What are you guys doing? And then I would get another code bases like, okay, this kind of makes more sense about why you'd use this here. But it was just,
preferred the data flow with functional and found it easy to test as well. Try both and broaden your horizons. Number 12, don't abstract too early.
For sure, that was this OOP stuff. Trying to abstract, it was like, oh, that's what was causing many problems.
Abstracting something too early in development could lead you down a path where it's difficult to come back from again. When you find yourself in a situation where you could abstract something, ask yourself these 3 questions. Do I know the majority of the cases where this abstraction will be used? Does the abstraction make sense not just to me, but to anyone else? Is the abstraction valuable, or is it...
Well, that's an easy one. Well, yes, of course. It makes total sense. Of course it is. It's an abstract factory singleton emitter. It's a value what you cover. Yeah. Well, this is all subjective here, but this is the one, the main question here. Do I know the majority of the cases where this happens? If you already have a hierarchy that needs some core thing that has a group of functions that all these things are going to, okay, yes. But generally, why are you making these crazy hierarchies, man? You just be real good to reason.
Simply hiding messy code. If you're not sure on the answer to these questions, then you might want to reconsider before moving ahead. Number 13. Forget dry and try damp. Most developers swear by this one, but there's one problem with it. We repeat ourselves all the time. It's a very concrete statement. Don't repeat yourself. That assumes forever, right? The problem is it needs a bit more nuance than that. There are times where repeating yourself is fine. If we abstracted or extracted every piece of code that we use twice, we'd probably never stop. A good rule of thumb I found is this. Have I coded the same logic at least 3 times? Can it be tested easily? Are there any special cases where I'm using this?
Yeah. So I'm a big fan of what was the phrase? Yeah, I say make sure it's wet before you make it dry. So write everything 3 times before you try and start to abstract it, and really think about, are these things all changing, or are they just changing all the same right now? Will they always be this way in the future? Maybe sometimes it's better to keep them separate. But if you're going back and like doing every time you go and change this thing, you're also changing this, then you go back and do it again, change this, and it really is something that's like that, don't think about it. But if it's just twice and it's like, might in the future someday, no. It's like when you get annoyed, that's when you know you should maybe do an abstraction. Be very careful, because it definitely complicates things, because it's so easy to get it more complicated. It's just so easy to think that you've got an abstraction, but you really just don't want to do this copy paste thing where it's maybe appropriate at that moment, but not in the future for all cases in general.
This. It forces you to think about the abstraction and whether it's valuable or not. Bad abstractions can create unwanted coupling and complexity. Number 14. Work
for sure
on communication skills early. This is a big one that can limit your ability to progress.
Okay. How do you do that without doing it, making some mistakes and flubbing and over time? You kind of. This is just comes time.
Your career. The further up the career ladder you go, the more important this skill becomes, because your duties and responsibilities expand, and your work becomes more about leadership, mentoring, guiding practices and principles in your engineering team and environment. You'll need to communicate with people from all parts of the business and adjust accordingly. If you can't communicate simply and effectively, then you'll struggle to build confidence for yourself
and just try and be as clear as possible, jargon free, and meet people at their level. If you're talking to another developer and they already know all the jargon, okay, fine. But if you're talking to a customer, it's just like, don't try and dumb it down, and don't try and make yourself look smart. They already know. The fact that you're doing a development work, they already think that you're smart. You don't have to prove anything to it. Just try and understand their problem and be as clear as possible. That's it. It's not that difficult.
And the team. Whack. Number 15.
And don't be a dick. If somebody doesn't understand what you're saying and gets frustrated, it's your problem to make yourself understood, not theirs to understand. Come on now.
Use the rubber duck. This vital piece of equipment can make or break a difficult problem you face. Okay, it's not like you have an actual duck. You can get the same effect by yourself or with another person. But
So by doing these videos and making these videos like this, you do actually automatically get this skill going if you don't have it. But I've always been doing this, trying to explain what my stuff does to other people since I was a little kid. So, but this is a valid debugging technique, trying to walk through and talk about it like as if you were on YouTube or trying to explain it to somebody else. Yeah, this is a great debugging technique.
Sure to use this technique. Rubber duck debugging has been widely documented as an effective way to break down problems when you're struggling.
And also getting up and walking away. If you're stuck in it and you're grinding on it for 30 minutes, sometimes just getting up, going or taking a walk for a little while, and then come back, drink water, and then sit back down again, or put the laptop down for the day, and go home, get rest, and tell yourself that in the morning you're going to have this thing, an idea of what's going to happen. Just have that thought, it's all right, but I'll have this figured out. And then you wake up, and sure enough, 8 times out of 10, it's going to have some sort of idea of what this could be, or another thing you didn't didn't or this thing you forgot, or you didn't do the thing over here, or whatever.
The basic principle is to explain the problem, preferably out loud, to the duck. Stepping through the problem with the duck makes you analyze the problem from a different perspective, and communicating clearly and precisely is a skill in itself. This will test whether you fully understand the problem or not. Go grab one of these bad boys so you can pass. I'll put a link in the description for this one. Number 16. If the duck fails, then take a walk. Sometimes not even the almighty Gandalf can save us. If that's the case, then get it up.
This is Steve Jobs' secret weapon. And I'm surprised more people don't use it, because I use it all the time. It's super amazing.
And going for a walk could be the answer. Everyone's heard of Steve Jobs' famous walking meetings. There's plenty of science that explains the benefits of walking, and I try and get in a daily walk of at least 45 minutes each day. I have a whole video where I talk about daily walks. You can go check it out. Whenever I've been stuck on a problem...
It's totally a thing. It's totally a thing, and you should do it. And if you don't do it, your back's going to get all fucked up from sitting down all day, and you do have to pump. You have lymph nodes that pump through and that only are exercised when you're walking and you're jostling. The lymphatic system doesn't have its own circulatory, so you have to pump it. by walking, getting a little bit of a sweat. And if you don't do that, you're just going to have back problems. This job will kill you.
And debugging with the duck out loud or somebody else just doesn't cut it. I find that getting up and walking away from the desk for 5 to 10 minutes will get what I need. It's a combination of movement and getting our eyes away from the screen that lets our brain process in a different way.
Yeah, well, it engages both through your hemispheres because you're doing the walking thing. So it engages both. And we are meant to be walking around and doing stuff physical. So that's what our bodies are for, not for sitting at these desks 10 hours a day.
Up from the desk more. Number 17. Be a lifelong learner. I believe you can never really truly master anything. Nobody ever goes to the grave completing everything in a given topic.
It's like, I've mastered the hammer. Well, so you can build anything. No, it's like, I've mastered it. So you can build literally like a bridge. Was like, I don't know about that. So it's like even then you're like, okay, I've mastered the hammer for the house. Okay, master the hammer to building bird feeders. Okay, bird houses. Okay, but have you mastered the hammer? It's like, it's ridiculous. All this software is, all this code, all this machine language. It's just a paintbrush. It's just a hammer, just to make something else. It's to get to make something else. So what is it like? What do you want to make? For who? Why? For what reason? What problem are you solving? Are you doing it for fun? Are you trying to make some money? Are you trying to facilitate something that doesn't happen right now? It's okay. That you can never master that.
Always more to learn. In that case, embrace being a lifelong learner. The goal is not to complete your training and then sail away happily ever after. The goal and the game is to constantly improve, constantly learn, and grow. It will be a lot easier if you embrace this and enjoy the process. Don't see it as extra work. Life is work.
Yeah, but it'll burn you out if you just try and do this all for as a job. It'll kill you.
Some of the most enjoyable parts of life come from being engrossed in a deep state of work and fun.
Yeah, right here. So we'll talk about in the adventure-driven development, right? I'm talking about here. This is where happiness is around here. So once you've been down here in these different things, tunnels of fake agile doom, scrum coach death, marches, hierarchical cults, tar pits of seemingly good ideas, lava licks of direct competition, dungeon grind, Jira, burn down shark, slog, factories, lead mine. And then if you get really good at coding, you're going to do a silver hoarding of the dev agency, consulting, mercenary, contracts, and happiness is up here. So when you're learning and stuff and engaging in like this dragon, doesn't have to be a product, whatever. You can be just learning about some new thing. It's like you're meeting all its objections. You're trying to figure out how this thing work. How is this thing designed? Why does this fit into what I already know? How is this different from what I already know? Etc. Etc.
Enjoy the learning. If you struggle to enjoy what you're learning, then try something else. Your intrinsic curiosity will guide you to things that feel like play but work for others. Number 18. Write more. It is a core skill for life. There is not a single profession in this world that is not improved by being able to write better. And it isn't being able to just write better for the sake of it. It's what comes from the writing itself.
How about express yourself more? That'd probably be a good thing. Even if you don't know exactly what's going on, people will correct you on the internet for free. Did you know that?
Writing is clarifying understanding. It's an incredible tool for learning. One of the most powerful tools you'll have for learning, discovery, collaboration, and communication. And specifically for programming, it helps with writing documentation, pull request reviews.
Yeah, like my whole guide, how to program from the ground up. The whole thing was me discovering all the tools that are built in to do all these diagrams and how much documentation you can do and links and all that stuff. I want to make a hyper document and you could do it all inside GitHub. And it's all just README markdown files. It's pretty awesome. But I wouldn't have done that if I wouldn't have done that whole course. I mean, I was thinking around with it, but that's expressing yourself. You don't have to be just all work tickets, blah, blah. You can do whatever. It doesn't have to be technical. It doesn't have to be. It can just be for fun.
Readability of code. Speaking of which, number 19. Get good at naming. The two hardest.
I mean, that's just a lifelong thing. By reading books and especially sci-fi books, the naming stuff gets easier as you read more like scientific words or more like fantasy type words. It's something that activates a certain sector of your brain for the naming stuff. And you always have a thesaurus, so you get good with the thesaurus.
These things in programming are caching validation and naming things. Make a real effort.
And off by one. There's always the off by one errors, and he missed that one because it's off by one. Never mind.
To work on the second one. Naming things is the difference between code people happily work with, maintain, and grow, and code that people can't follow, update, or understand. Keep naming simple and readable. For example, use adjectives and variables names to describe its.
Yeah, for sure. So I have a style guide that's in my GitHub. It's in Fred's Road Trip Storyteller. You can look, there's a link to it down there. You can look at the style guide I have for it, and this is the kind of stuff that you wanna start doing. Like for sure. This is I prefer is like using is almost everywhere because it's a Boolean right then. So there's a bunch of things like that, and if you don't have a style guide started for yourself, that even if you don't use that at your current company that you want to use on your own projects or whatever, it's really great to create your own style guide. You definitely should be done. You should have to do that as a developer. Make your own style guide for sure. Just because it's useful to know that how to structure things well, and by putting yourself in that mode of thinking, you start to pay attention to it.
Content, so people don't have to look at what's in it, they know what it's being used for. Number 20, KISS. Keep it simple, stupid. A widely used phrase in programming. Simple is hard to achieve, so it's important to take our...
Yes, it's very hard to achieve. It's difficult to achieve because you have to know what you're doing, and sometimes we don't know. So a lot of programmers think that they got to go with their prototype and they have to extend their prototype. Just throw that puppy away and start over with what you've learned, with everything you know. Now do the draft 2. I don't know where people get, like, my English teacher always like, we're going to do a rough draft, and then we're going to write the final paper. And you might do 2 rough drafts. And it's just rewriting it. It's all it is rewrite. It's not restructuring it. It's just rewriting it as you know. Like, we're just trying to put all the stuff you figured out from doing the prototype into the MVP. And then with the MVP, take everything you've done from that and put that into the production version. This is not difficult. Don't try and make it something different along the way. No, just make it that thing you just figured out. All the problems that you wished you was different away, do that again and throw it away. Why are people so, we got to keep the source code and upgrade the prototype to the MVP? We can't rewrite it now. It's like, well, you're going to have a lot of problems in production, man. Security holes, all kinds of stuff.
Our time, break things down, and find a way to make complex things simple. Simple does not mean easy. Simple is an art and it's difficult to achieve. Avoid getting dragged into needless complexity.
Yes, this is one of the most popular things we developers love to do, is needless complexity. Let's add all this bloat, let's pre-bloat this thing with all kinds of testing, CI/CD pipelines, AI tools. It's like all this stuff. Like, no. How about we don't? How about we just get product market fit and have more servers, more customers and servers, right? So let's not go overboard here. Let's try and get the customers through the door, and then we can add this stuff on as we need it, not just because we have to, because Google did it. That's because Microsoft does it as standard or things. Look, it's built into the tool. Look, it's like, no, you don't have to add all that stuff. We don't have to have a massive suite that takes 45 minutes to run of tests. Come on. You know, we have to run every time we do a commit. It's like, come on, stop.
It is the death of software. The more complexity you introduce, the more chances you create for your code to fail. Strive for simple. Number 21, use comments in your code as a last resort.
Yeah, only for why. Only for why. Only for why. Or there's some weird workaround thing you're doing and you want to put the link in there. Okay, that makes sense. Like, that just the reason is why. Like, never what, never how, why. It's usually just a short thing. It's like, this is a hack to do blah, blah, blah. Or check this reference here. That's a link to your GitHub document. I mean, if you're trying to use actually when you write the code, good variable names, so it makes it obvious what the hell's going on. And it's usually just going to be a filter, extract, map, transform. Okay.
Apart from packages, libraries, and modules, I really do feel like commenting your code is unnecessary. Don't feel the need to comment every line of code.
Definitely don't do that. That's horrible because they get out of sync really rapidly, right? Really rapidly. Just like, why is this thing? And maybe the header stuff is just like, what does this function do? Just a short little blurb. What the function does. Bloop. It should be obvious by the name of it, but like double do it. That's acceptable. But don't every line. Where'd that come from? It's silly.
And documentation isn't the same as commenting code. Good engineers can understand what code does by following its path, looking at the variable names, if it's named well, and essentially the code becomes the documentation.
Yeah, that's the whole idea. Yeah, like reading like a book. It's not. It can be. You don't have to try and make it as simple as possible. Explain it to somebody else, not so you can understand, but somebody else can understand it. By showing them and asking them, hey, do you understand this? If you can't, it's like really like as if you. So this comes with time, right? As if you've walked up to the thing for the first time and you're reading it for the first time, and it makes sense the first time through. Like, it would make sense to someone like, what the hell's going on? Not just A equals X, Y. No one character variables unless it's a counter, right? It's like, come on, there's all these rules. And I have it in my style document if you want to check it out.
If something is particularly complicated and it's not obvious how to make it simpler, or if its usage is confusing, then do reach for the comments, but use them sparingly.
Yeah, for sure.
Two Little Ducks 22.
Because they get out of sync so rapidly, and it's super annoying when the comments say one thing and the code does something else completely. It's super annoying. I know, it's super annoying.
Study with materials, learn with projects.
Yeah, for sure. For sure. So it's like copying, for sure, like doing the muscle memory type, not just looky, copy, but actually typing in the code, especially in the beginning, is the only way you're going to get this stuff to like get inside your brain. And then trying to modify them and not just skipping on to the next tutorial, like trying to modify them, doing your own thing with them, and doing enough of those. And so your brain gets kind of wired up with doing that with your fingers. You actually have to do the typey. You can't do the. This is a secret. I know it makes no sense, but this is how our brains work, right? So if you do the typey, then it'll transfer in your brain after a while, and you can't skip it. And you're just like, I want to go faster. No, your brain takes as long as it takes. And if you're the kind of person that needs 10 of them, it's going to take 10. If you're the person that needs 3, you do 3. And that's just how it goes.
We gather and collect knowledge by reading, listening, and watching. We learn through implementing, creation, and action. Don't get stuck in tutorial hell. You'll learn nothing.
Absolutely. The tutorial tar pits. Do not get caught. It's really super tempting, but you have to do the typey. You have to look at what they thing is doing, and you type it yourself. Look at what they're doing. Type it yourself. Don't copy their GitHub. And then once you've done that enough times, your brain will start to slowly click in. If you're slow like mine. But then eventually, once it's thin, it's yours. You're not going to go back. You don't understand how it's all put together because you'll have typed it in so many times. So that's another key. Also, how to get out of writer's block.
Once you study some information, test yourself on it. Use it. Make something. Programming is a skill.
Yeah, you gotta make something. Gotta have a customer. Gotta have somebody you're trying to build something for, even at the beginning. So that's just how it goes. This is how it works. We say the same thing over and over again because this is the only thing that actually work. With the people have tried all kinds of other things, all kinds of Pomodoro times, blah blah blah. But the only thing that actually does it is getting the hands on the keyboard, trying to make something, usually for someone else, and trying to fix their problem somehow, even if it sucks first. That's fine. Just keep going with it. That's just how it works.
Craft, a creative outlet, and you simply don't learn through passive activities. There's a great video by Python programmer which explains that creating is the highest order of learning.
Yeah, I think that's true because you have to bring everything. You bring your whole self to bear, and it exposes what you don't know, and it's super embarrassing to know all the things, but you really want to know all the things. But that's the process. It's looking a little bit foolish. You have to look a little bit foolish. You have to look a little bit. Where is it? Silly. That is the quest. You're doing something that is people normally don't do because you're exposing that you don't know everything. And by going on the quest, you might hit another mountain, you might fall off the map, but you're going to learn and create. And you'll be gaining enlightenment. How's that? You're gaining awareness of yourself and the universe and how it's put together.
Number 23, start with small projects that pique your curiosity, then work up. It's easy to see what people make online and get a bit jealous. Or it might be desire, excitement, whatever you feel when you see something that someone is creating that looks great. But when
Yeah. For sure. That's definitely like, oh my God, how did they fucking do that? That son of a bitch. They're not, I want to know how to do that. If you get that little zing, like that son of a bitch, that's when you're supposed to go look into it. That's your soul giving you like your heart, your soul, your whole soul, your soul singing, your heart singing is when when you feel that tinge like, hey, I want to know how that fucking thing works. And that son of a bitch, he knows how to do it. Well, let me give you a little secret. If that dummy can do it, this dummy can do it too. So it's like, so when you feel that little thing, that's when you have to like go after it. If you don't, and if you deny that voice, that little voice that says go look into that for too much longer, that's when you get to the burnout. That's when you get depressed. Everything sucks, whatever. But so you have to let it. You have to let it chase. You have to chase it. You have to let it run. If you don't, I could find something else.
When starting out, it's better to start off with small problems and projects and work our way up from there. Seeing something through to completion is a skill in itself. If you tackle something too big, too early, you'll struggle to see it through to the finish.
Seeing through things to the end is also another key thing. A lot of people pick up things. You can do that sometimes, but it's really best if you can get something that's operable, and you just start off with something small that you know you can get done, then do the next thing, next up. Then you take a little big board too big. It's like, oh, okay, I can't do that. All right, let's go back to and you keep doing that, and eventually you'll have a pretty good idea of how it's all put together and can get to bigger projects. So that's not mystery.
If you're curious about building something, then try and pick off a feature or piece of functionality that you can tackle on its own. You can build it end to end and learn its ins and outs in greater depth. Number 24, write your code in long format to start with.
Yes.
This might sound weird, but for some programming languages, it's a good idea to write out the longhand format. For example, in CSS, there's multiple properties like margin, padding, border radius that encapsulate multiple properties into one. If you write it out with each property defined individually, you'll understand all the components that go.
He's just talking about CSS stuff. This is sort of an implementation thing for the web. I don't even know. It doesn't really apply to compose. So
It's that one encapsulation, some of which you might not have known of or understand without doing so. Number 25, build a framework or package. If you find yourself using the same...
I don't think you should do this. Just learn Compose, learn KMP, learn Android, learn iOS, how they do things. You don't have to learn more frameworks. I guess those are frameworks, right? But you don't have to just learn all that. You don't have to do that. You can just learn. You can learn pieces of those at a time as you learn KMP. As you get into KMP, you can learn one of the platforms. Is probably Android, probably first, or web, or desktop. A lot of people coming from the desktop thing. But now iOS is open, so we're gonna have a lot of people coming into and working with the iOS. So that's just but you're on the core of KMP, but you're gonna learn pieces of iOS. Like I've used in Fred's Road Trip Storyteller for the space synthesis and for the map and to what else? The billing for so on iOS you use Apple's billing, on the Android you use Play Store's billing. So it's that kind of stuff.
Copy-paste code between projects, then go a step further and create a shared package or module. If you want to understand how React.js or Vue.js really work, then try and implement some of the features in your own framework. There's a big difference between code...
I just do web components for that, and just don't forget about these frameworks. But I can understand what you're saying.
We produce for ourselves and teams, and creating something that can be distributed, shared, and used through open source.
I don't know about that. They may have been valid in 2015, but don't do that today. That's probably not a good idea.
We'll teach you invaluable lessons about coding. Number 26, build a CLI tool.
This I agree. So with Kotlin scripting, you can totally do basically do anything you do with JavaScript or Bash, you can do with Kotlin and Kotlin scripting. So CLI tools for doing who knows what, but building them in Kotlin, definitely cool.
This one can be a lot of fun. We spend a lot of time in our terminal tools and we use a lot of things through the terminal. Build something you can use that improves your workflow or just something for fun. It's a very different experience than writing most software you do day to day. And it can be a really exciting talking point you can have with other developers as well. Number 27, get friendly with logging. Monitoring.
I mean, yes, logging is important. And there's definitely an art to logging, and overlogging is definitely a problem. I like to be very verbose and wordy with my logs because I can look at it and I know exactly what they're talking, what's going on there, and what's going on, and it's obvious to me. Sometimes I get a little overboard, but it's better than to not have any errors should be logged out for sure. Any warnings should be. I don't know. The warnings are in a gray area because people just tend to ignore them.
Monitoring and observability of systems is vital for production software. You need to be comfortable with implementing logging mechanisms, but also comfortable in reading logs, accessing logs in various ways, and debugging using logs.
I mean, logging is, yes, it's important, but having a more effective, for VPS, like an individual instance, logging is key, and for bigger ones too. But we definitely have to use more advanced monitoring tools that don't rely on logging, because I've seen people use these logs that people just ignore them. There's just a bunch of garbage that we have no idea even what it is or where it came from, what it's for. And the monitoring was weak, or they had a bunch of Slack messages that were just popping up these graphs. And it's very difficult to monitor. So once you could get multiple servers, monitoring that and looking for crashes and inefficiencies and overloads and all that stuff, it becomes more critical. But that's way down the line, and you can take care of it then.
They're a window into what's happening in your applications and gives you visibility of potential problems ahead of time. Number 28, handle your errors explicitly. Some languages do this better than others, but if you know a potential error could occur, then handle it explicitly. Some languages force this, like Go, but some languages like JavaScript will fail for many reasons, and there won't be any clues as to where it could.
Yeah, with KMP, it's not as big. You're definitely going to get a stack trace.
Fail. If you know something that might fail, then cater for that. Number 29, use the debugger. Everyone uses console log, print, echo, whatever it may be to debug our code. But using an actual debugger will give you insights into what's happening in your code, where, and in what order things are happening. They're not hard once you understand what it is that they're doing and learn the basic controls. They improve your ability to debug massively. Number 30, get comfortable not knowing. A lot of time during programming.
Yeah, there's a lot of stuff you don't know. You just have to skip over it until it becomes important, then you have to get into it. That's just how it goes.
You're going to feel lost, frustrated, scared, and even a little bit...
Yeah, for sure. It's most of it's what the hell? How's this work? I don't know how this works. Does this work? Is what I'm doing actually possible?
But that's part of the parcel for learning anything. You're not going to know how to do something until you've done it at least once. You won't know how to build a web-based calendar component. You won't know how to build a search-based API. You won't know a lot of things. There's no manual. There's great resources online, but not for everything. You have to be comfortable being uncomfortable.
That's where the AI stuff really does help out, but you have to know what it's saying and how it all fits in, and that part you can't skip, right? How the systems are all put together, how CSS works, how HTML works, how Kotlin works, how Compose works, how all of these, how these build systems work, how Gradle works. You kind of have to know that stuff, and then the AIs can really help. And the AIs do help kind of learning with it, but you still have to go through that process. You can't skip it. That's the thing. That's I see a lot of these juniors online using these AI tools to try and skip that stuff. You can't skip it, man. AI will definitely help way more after you understand what's going on, but you can't skip it.
Comfortable in order to grow. The majority of software and programming is problem solving. You'll need to accept not knowing and instead break problems down until you can solve it. Bonus tip number 31. Keep working on the fundamentals. Avoid shiny framework syndrome. AI...
Shiny framework has been really bad. It's been really bad. And diving into, like, if you get really good with Kotlin, get deep into the fundamentals of that, every other language becomes like, oh, okay, they just do it like this. Oh, they do it like that. Or they don't have that. Or they put this or do this way. Or that syntax is weird. Why do you do it like that? That seems odd. Maybe you should have done it a different way. You know, that kind of
It's everywhere right now. People think traditional coding will die off. It might, but that time is not now.
No.
Learning the fundamentals...
There's always going to be a layer of customizability that's going to be written in some language that's going to need to be human readable. We're not going to be... AIs can suggest this stuff, and maybe 20 years from now, they'll be able to handle some of these things. But even then, it's just easier to write the code.
Will always serve you well in the long run. If you understand code at a deep level and the fundamentals of software engineering, you'll be able to adapt to any language, any framework, any tool, and be able to keep moving forward. There's a great quote from Kobe Bryant that says, "I never get bored with the basics."
That's actually true. And it's all in the basics. Like I said, IBM's found out 80% of their code is, filter, map, transform. And that's, okay, how... It's the thing about it is, are you saying I don't get bored with hammering stuff? It's like, I don't get bored building stuff. I like making stuff. I like making things come up. And whatever I have to do, whatever I have to learn, whatever I have to get through to do that, I'll try and make it enjoyable, but that's just a means to an end. The hammer is just a means to an end. Now, I'm going to get good at it because I want to build something. I want to make something possible that hasn't been seen before, right? That's where that's the impetus, right? The creator-destroyer impetus. But what do I really like hammering? It's the most useful tool for what I need, for everything I need to do. But if there was a way to not do hammering and still get the things done, I'd probably do that.
The best in the world at anything all master the basics, the fundamentals. It's not fancy tricks and complex skills they know that makes them the best. It's mastering the fundamentals. That means they can adapt to any situation and consistently stay on top. Don't follow the next shiny framework.
Stay on top consistently. You're going to be confused a lot.
It comes along just because. Do it for fun if you wish, but don't drop everything else in place of it. Keep working on the fundamentals. If you like this, then check out this next video where I share insights on what great developers do versus the average developer. Click it, please.
All right.
Welcome to the
All of the time.
So give him a like and subscribe. That was just automatically forwarded to the next one. I'll probably have this auto play on. Or here, where am I going? All right, so that's a little bit of my feedback on some of his 10 years of experience on developing, and I concur with most of it. Go give him a like and subscribe. I'll leave the link in the description below, and I'll see you soon. Get the cloud here.